Hi, and welcome to day 2 of Just Start Programming, creating console terminal apps using Rust and Ratatouille. So if you have just discovered my live YouTube video, this is the second series of my learning journey. I would suggest that you watch my first series where I started learning Rust. 40 videos spread across 2 months. It's not easy, but just be patient and go through it 1 to 2 hours each day, and who knows, the next time you look at Rust code, you might be able to understand how it works. The first time I saw Rust code, it is really difficult to understand, but now it felt a bit more or less difficult as it was before. But I have barely scratched the surface, and that's the reason why I'm taking a step further by trying out console apps or terminal apps. So I have to say this once again, this is not a tutorial, this is a learning journey. All right. So yesterday we were setting things up and tried the Hello Ratatouille app and the counter app. So today we'll try out the JSON editor example from Ratatouille website. So join me once again live in one take, no shortcuts and no secrets. So let's just start programming. All right, so here we are from the Ratatouille website. This is the JSON editor example. So let's go through it together. So yesterday we did the Hello Ratatouille and counter apps. So now we are ready to build and manage something more involved. Okay, so in this tutorial from Ratatouille that is, we will be creating an application that gives the user a simple interface to enter key value pairs, which will be converted and printed to stdout in JSON. The purpose of this application will be to give the user an interface to create correct JSON instead of having to worry about commas and brackets themselves. Here's a GIF of what it will look like if you run this. Okay, so it's still in the console or in the terminal. You can create new JSON. There's a pop-up, specify the key and the value. Q to quit. Is there a command to save it? Okay, let's go through. So initialization, go ahead and set up a new Rust project with cargo new Ratatouille JSON editor. So let's copy this one from here. Let's come out from Ratatouille counter app, and then we do a cargo new Ratatouille JSON editor. and put the following in the cargo.toml. Let's copy this part. What do we have here? Dependencies. Okay, so Ratatouille 229. Third day, and then third day JSON. So this is something new here. So hopefully the version matches with the code snippets in this tutorial. Or the latest version of these libraries. Yeah, but we'll just copy this and hopefully it will match with the code snippets. Okay, then now create two files inside the stores. So it looks like this. UI and app. So here we can create UI.rs and then app.rs. And we can check this also here from the command line, although it's not specified. You do a tree command. Oops, I think probably because it was compiling it. We should see something here at the top. Yeah, source, app, main, and UI. And then this follows a common approach to small applications in Ratatouille, where we have a state file, a UI file, and the main file to tie it all together. Which one is state? We don't know yet. Oh, you have a UI, so probably the state file is the app, and then you have the main.rs. Okay, let's move on. App.rs. As we saw in the previous section, a common model for smaller Ratatouille applications is to have one application state struct called app, or some variant of that name. We will be using this paradigm in this application as well. This struct will contain all of our persistent data and will be passed to any function that needs to know the current state of the application. So there will be an app struct, just like the counter app the other day. Application modes. It is useful to think about the several modes that your application can be in. Thinking in modes will make it easier to segregate everything from what window is getting drawn to what key bindings to listen for. You'll be using the application state to track two things: what screen the user is seeing, and then which box should be highlighted. Key or value, this only applies when the user is editing a key value pair. Current screen, enum. In this tutorial application, we will have three screens: main, editing, and exiting. So the main summary screen showing all the past key value pairs entered. Editing is the screen shown when the user wishes to create a new key value pair. Exiting displays a prompt asking if the user wants to output the key value pairs they have entered. we represent these possible modes with a simple enum. Okay, so current screen is an enum, main, editing, and exiting. Okay, so it's a code. Let's copy this. So this is under app.rs. So let's open up app.rs and insert it here. Okay. Currently editing enum. Editing. As you may already know, Ratatui does not automatically redraw the screen. Ratatui also does not remember anything about what it drew last frame. This means that the programmer is responsible for handling all state and updating widgets to reflect changes. In this case, we will allow the user to input two strings in the editing mode, a key and a value. Programmer is responsible for knowing which the user is trying to edit. For this purpose, we will create another enum for our application state called currently editing to keep track of which field the user is currently entering. So currently editing, so it seems like it's under editing just to have key and value. Okay, so let's copy this. This is still under app.rs. Okay. The full application state. Now that we have enums to help us track where the user is, we will create the struct that actually stores this data, which can be passed around where it is needed. Okay, so app is considered as the one that stores the data. Okay, so let's copy this. And let's read through the comments. So struct app, key input, currently being edited JSON key. It's like your key field input or key text field probably. Value input, the currently being edited JSON value. So they go in pairs, key and value. Pairs, and you have a hash map, string and string. So the representation of our key and value pairs with third day serialized support. So I don't know third day as well, but let's see. Current screen. Okay. The current screen the user is looking at and will later determine what is rendered. Current screen is an enum. Currently editing. So this one you have an option. Usually you have some and none, or some or none. And inside that you have this enum currently editing. The optional state containing which of the key or value pair the user is editing. It is an option because the user is not directly editing a key value pair. This will be set to none. Be none by default. Helper functions. Well, we could simply keep our application state as simply a holder of values. We can also create a few helper functions, which will make our life easier elsewhere. Of course, this function should only affect the application state itself and nothing outside of it. Okay, so helper functions. The first one is new. We'll be adding this function simply to make creating the state easier. While this could be avoided by specifying it all in the instantiation of the variable, doing it here allows for easy to change universal defaults for the state. Okay. So let's copy this one. So this is the start of the app implementation. App as in the abstract. Okay, so when you call new, it will create something like this. String new hash map, current screen main, and currently editing none, which is an option. Okay. Save key value. This function will be called when the user saves a key value pair in the editor. It adds two stored variables to the key value pairs. So it adds it to a hash map and resets the status of all the editing variables. Okay, let's copy this code snippet. This is still part of the app. You can append it here. Let's see if it will compile. Okay, so it compiled. So what do we have here? Save key value self as a reference to mutable self. Yeah. Then self.pairs. So it's like accessing this one, self.pairs. Since it's a hash map, so we are inserting. Insert key input clone. Do we have clone? Because key input is a string, and string implements a clone. Okay, then the same for value input clone. Then you have self key input string new value input string new, currently editing none. Okay. Toggle editing. Why do we need this one? Okay. Sometimes it is easier to put simple logic into a convenience function, so we don't have to worry about it in the main code block. Toggle editing is one of those cases. All we are doing is checking if something is currently being edited. So checking if something is currently being edited. And if it is, swapping between editing the key and value fields. Toggle editing. Okay. Let's copy this first. So that is still part of app. Okay, so it will look like this. No compilation issues. What does it do? You have a reference to self currently editing. It's currently editing. Okay, currently editing is this one, which is an option. If okay, so if it is a combination of if let. So if currently editing returns some, which is edit mode. So edit mode is currently editing. Where's the edit? Where's edit mode? I don't see the edit mode somewhere. Okay. Okay. So this one currently, okay. So because currently editing is an option, and option will have some or none. So whatever value this one has, it will be here in edit mode. And there's a match expression here, keyword, where it match edit mode to the enum currently editing. Is it an enum? Yeah, enum currently editing, where you have key, key, key will be, if it's key, then currently self currently editing equals some currently editing value. And then currently value would be currently editing key. Okay, why is it the opposite? Is there a mistake? Yeah, so key is here, value is here, value is also here. Okay, so it's like, okay, because it's toggle editing. Okay, so if you're currently editing the key, then you toggle it. So it's like a switch on off switch. So now you are editing value. No, if you are editing key, to toggle it, it means that you'll be editing value. Yeah, so that's why it's the opposite. Okay, and then if other than some, it could be none else, then it falls under else. Currently editing, so I think by default it starts off with key. That's why you have it here. All right. Then print JSON finally is another convenience function to print out the serialized JSON from all of our key value pairs. Okay, so let's copy this one. Okay. Print JSON. Third day is something new. Okay. So it will return a result from this third day JSON. Okay, third day JSON to string at self.pairs. So it's referring to the value of pairs. So it will be, I think, serialized. It doesn't say. Okay. So pairs will be converted into a JSON string, probably. I'm just guessing. Yeah. But let's see what's the output later on. Okay. So there's nothing much explanation that we can see here. Hopefully in the next sections we'll see some explanation. Okay. In Ratatouille, every frame draws the UI anew. See the rendering section for more information. Rendering section. The world of UI development consists mainly of two dominant paradigms, retained mode and immediate mode. Most traditional GUI or graphical user interface libraries operate under the retained mode paradigm. However, Ratatouille employs the immediate mode rendering approach for terminal user interface development. This makes Ratatouille different from GUI frameworks you might use because it only updates when you tell it to. Okay, so it's an immediate rendering approach. And let's move on to main.rs. Okay, the main file in many Ratatouille applications is simply a place to store the startup loop and occasionally event handling. See more ways to handle events in event handling. Event handling. What do we have here? Centralized event handling, caching. Okay, so we'll go through the concept in some other days. Yeah. But for now, let's just focus on this example. In our main function, we'll set up the terminal, create an application state, and run our application. And finally, reset the terminal to the state we found it in. Application pre-run steps, because Ratatouille application takes the whole screen and captures all the keyboard input, we need some boilerplate at the beginning of our main function. Okay, so I'll be copying this. So main function, let's come back here to main. Okay, so that one will say it's unused, that is fine. And then in main, we have this code snippet. So it's not hello world anymore. Okay. Error. Which error we are talking about, we don't know yet. Or it could be survey error. Okay. You might notice that we are using stdr for output. This is because we want to allow the user to pipe their completed JSON to other programs like Ratatouille tutorial, output.json. To do this, we are using the fact that stdr is piped differently than stdout. We render output to stdr and print our completed JSON to stdout. For more information, please read the cross-term documentation. Cross-term. stdout. Okay, so we have something here, stdout, and there could be stdr here somewhere. Okay, let's close that. State creation and loop starting. Now that we have prepared the terminal for our application to run, it's time to actually run it. First, we need to create an instance of our app to hold all of the program state, and then we will call our function which handles the event and draw loop. Okay, so this is part of main. Where do we put this? Probably here. Okay. Now we have errors. Okay, that is fine. Application post-run steps. Since our Ratatouille application has changed the state of the user's terminal with our pre-run boilerplate, we need to undo what we have done and put terminal back to the way we found it. Most of these functions will simply be the inverse of what we have done above. Okay, so it says here it's time to actually run it. Okay, but we are having some errors. Let's see, run app, cannot find run app in this scope. Don't have run app. Import Prelude, okay. Terminal. Import Ratatui. Terminal. Okay. And then error. Quick fix. Import error. Which error? Which error? Okay, let's go with stdio error. App is here. Is there an error in app? Is there a quick fix? Yes. Insert. Okay. Run app. Cannot find function. Run app. App new save toggle print JSON. We miss anything? Main. Okay. I copy this. Copy this. Did we copy this part? Where is that? First, we need to create an instance for app to hold the program state. And then we call our function, which handles the event and draw loop. Custom backend. Where is that? Do we have it? Custom backend. Terminal. Yeah, it's here. Yeah, and this one. Where are we? Okay, we are using this one. State creation. We have this post run steps. Now that we have prepared the terminal for application to run, it's time to actually run it. But we cannot run it yet. There are still some issues. Consider importing one of these straight instead. std error. Okay, so let's remove this one. And then here, quick fix, import error. Which error? std error. Okay. Then IO, import IO. std IO. Okay. Then app, undeclared type app. Use of undeclared type apps. Click for full compiler diagnostic. App is here. Public struct app. Okay. And it's also here. use app. I cannot use app as well. How do we use app here? Let's look at counter. Okay, so this one, everything is here actually. Implement app, run. Why? Ratatui. JSON editor. Cargo build. Yeah, so we cannot build it yet. So I'm just wondering if we can actually run it. Okay, maybe let's just continue for now and see. Okay, application post run step. Since our Ratatouille application has changed the state of the user's terminal with our pre-run boilerplate. Jumps back here. We need to undo what we have done and put the terminal back to the way we found it. Most of this function will simply be the inverse of what we have done above. Okay, so here, let's copy this. There's this code snippet, disable raw mode execute. So this one should have okay, so there's terminal here, maybe around here, and then comment out this part, and this one compiles. Okay, when the application exists without running this closing boilerplate, the terminal will act very strange, and the user will usually have to end the terminal session and start a new one. Thus, it is important that we handle our error in such a way that we can call this last piece. Last piece. Is it referring to this one? Before okay. So maybe I'll just append it here. Res. What is this? Cannot find value res in this scope. What is res? The if statement at the end of the boilerplate checks if the run-app function errored or if it returned an OK state. If it returned an OK state, we need to check if we should print the JSON. OK state, and we need to check if we need to print the JSON. If we don't call our print function before we call execute, leave alternate screen, our prints will be rendered on an old screen and lost when we leave the alternate screen. For more information on how this works, read the Rust term documentation. So all together, our finished function should look like this. Okay, so it looks like this. App is still here. Let me copy everything. Then this one, since there are so many issues, we just comment this out. Put this one instead. App and run app. Yeah, so we're missing app. Okay, I think app should be calling this one because we have new here. It should have this one. Okay, let's continue. Run app. In this function, we'll start to do the actual logic. Let's start with the method signature. Oh, okay. So run app is actually here. Okay, so let's copy this one. Should be inside main. IO result. Maybe let's just put okay for now. And then we're missing the backend. Okay. You'll notice that we make this function generic across Ratatui backend. In previous sections, we hard-coded the cross-term backend. This straight approach allows us to make our code backend agnostic. This method accepts an object of type terminal, which implements the Ratatouille backend trait. This trait includes the 3 for counting the test. What was this? This trait includes the 3 for counting the test backend. Okay, so it means it's 4. Officially supported backends included in the Ratatouille. It allows for third-party backends to be implemented. Runup also requires a mutable borrow to an application state object as defined in this project. Mutable borrow, okay. Since app is the state object. Finally, the runup returns an IO result bool. Okay, that indicates if there was an IO error with the ERR state and an OK true or OK false that indicates if the program should print out the finished JSON. Okay, UI loop. Because Ratatouille requires us to implement our own event UI loop, we will simply use the following code to update our main loop. So there's a loop. Main loop. Let's copy this one. Terminal draw. terminal draw. Okay, so this is the main. Run is where? Run up is here. Okay, so just my assumption, the loop should be here. Okay, let's put it there for now. Okay, we don't have UI yet. Okay, let's unpack draw call really quick. Terminal is the terminal backend. Yeah, so terminal is the terminal backend, B for this backend. Preloop backend. Okay, let's see. Draw is the Ratatui command to draw a frame. Okay, so once you have terminal, then terminal draw. Okay. And this one is a closure. It tells draw that we want to take frame and pass it to our function UI. Function UI, and UI will draw to that frame. UI will draw to that frame. Okay, but we don't have UI yet. Notice that we also pass in immutable borrow of our application state to the UI function. So we're borrowing, having this ampersand sign. This will be important later. Event handling. Now that we have started our app and have set up the UI rendering, we will implement the event handling. Polling. Because we are using cross term, we can simply poll for keyboard events with if event key equals event read, and this one, and then match the results. Alternatively, we can set up a thread to run in the background to poll and send event. But let's keep things simple here for the sake of illustration. Note that the process for polling events will vary on the backend you're utilizing, and you will need to refer to the documentation of the backend for more information. Where do we put this one? If event. Loop, probably inside that one. Okay, let's copy this and put it here. Event. Debug. Let's comment that out. Okay. Main screen. We will start with keybinds and event handling for the current screen main. Event. And this is the main screen. Where do we insert this one? If let event key event read. Okay, so this is when you're reading the event current screen. Okay, maybe let's not copy this and skip it for now. I'm sure we will see that somewhere in the code also, and some explanation. does it say here? Okay. After matching to the main enum variant, we match the event. When the user in this main screen, there are only 2 keybinds and the rest are ignored. So only 2 keybinds. Is it referring to key event release, E and Q? In this case, key code car E changes the current screen to editing and sets the currently editing to some, and notes that the user should be editing the key value field as opposed to the value field. I think there was a toggle function in app. Okay, but in this case, okay, when E is pressed, so the current screen becomes editing, and currently editing becomes some currently editing key. Okay, so E is editing the key. If Q, then current screen exiting because it's Q. Okay. Q is straightforward as it simply switches the application to the exiting screen and allows the UI and future event handling runs to do the rest. Exiting. The next handler we will prepare will handle events while the application is on the current screen exiting. The job of this screen is to ask if the user wants to exit without outputting the JSON. It is simply yes/no question, so that is all we listen for. We also add an alternate exit key with Q. The user chooses to output the JSON, we will return an OK true. That indicates that our main function should call appRintJSON to perform the serialization and printing for us after resetting the terminal to normal. Current screen exiting, match. Okay, where did we have the current screen exiting? I think that is in app. Yeah. But I think this one is still under main. Okay. Okay, so editing. Our final handler will be a bit more involved as we will be changing the state of internal variables. We'd like the enter key to save 2 purposes. When the user is editing the key, we want the enter key to switch the focus to editing the value. However, if the value is what is being currently edited, enter will save the key value pair and return to the main screen. Okay, so enter key. So if you are editing the key, we want the enter key to switch. So after key, you press enter, and then the focus will be the value. If value is the one you're editing, when you press enter, it will save. So maybe that's why in the animation there was no save key. So after value, you press enter. It will just save the key value pair and return to the main screen. Okay. Editing key. Okay, then after key, it moves to value, it will save. Okay, Save key value. I don't think we have that one here. Oh, we have, okay. When backspace is pressed, we need to first determine if the user is editing a key or a value, and then pop the endings of those strings accordingly. Backspace. Okay, so if you press backspace, why will it pop? App, key input, pop. That was key input. Key input is string. Okay, so seems like pop will remove the last character. Probably. When escape is pressed, we want to quit editing. Okay, so escape. Current screen becomes main. Currently editing done. When tab is pressed, we want the currently editing selection to switch. Okay. Tab. So when you press tab, it will switch between key and value. Okay. And finally, if the user types a valid character, we want to capture that and add it to the string that is the final key or value. Altogether, the event loop should look like this. Event loop. Oh, okay. So this one goes inside the event loop. Let's copy this. Where's our event loop? It should be in main. Terminal draw. Event key. You need to delete this part. Insert that one. Technically, this is the command to the terminal backend, but that only matters on the test backend. What does it mean? I don't know what that means, but let's continue with this one. UI.rs. Finally, we come to the last piece of the puzzle and also the hardest part. When you are just starting out creating Ratatui TUIs, the UI, we create a very simple UI with just one widget in the previous tutorial, but here we explore some more sophisticated layouts. Note, if you have created a UI before, you should know that UI code can take up much more space than you think it should, and this is no exception. We will only briefly cover all the functionality available in Ratatui and how the core of Ratatui design works. There will be links to more resources where they are covered in depth in the following sections. Layout basics. Our first step is to grasp how we render widgets onto the terminal. In essence, widgets are constructed and then drawn onto the screen using frame, which is placed within a specified rect. Now envision a scenario where we wish to divide our renderable rect area into 3 distinct areas. For this, we can use the layout functionality in Ratatui. Okay, so you'll have a layout. Direction, vertical, then constraints are the constraints. It's an array of constraint. Length 3, min 1, length 3. I don't understand this as well, but let's just continue. This can be likened to partitioning a large rectangle into smaller sections. Okay, so rectangle, length 3, minimum is 1. The length of which one? We don't know. Minimum 1 and length 3. Split, frame, area. Okay. Yeah, so at this point it's still difficult to visualize. In the example above, you can read the instructions aloud like this. Okay, so here's the guide. Take the area F, that area which is a rectangle, and F is the frame, and cut into 3 vertical pieces. Okay, because the direction is vertical here. Making horizontal cuts. Vertical, okay. Okay, so it's vertical, but you're cutting horizontal. The first section will be 3 lines tall. Maybe it's referring to this. 3 lines tall. The second section should never be smaller than 1 line tall, but can expand if needed. Okay. So that's why it's the minimum. The final section should also be 3 lines tall. Okay. For those visual learners, I have the following graphic. Thank you. Very good. So here, okay, so we're defining a vertical, but you're actually cutting it horizontally like this. So length 3, and here it's like, as long as you have a minimum of 1, so it can expand. And then here you have a bottom segment, length equals to 3. Now that we have that out of the way, let us create the TUI for our application. Function signature. The function signature. Our UI function needs 2 things to successfully create UI elements. The frame, which contains the size of the terminal at render time. This is important because it allows us to take resizable terminals into account, and the application state. Okay, before we proceed, let's implement a centered rect helper function. This code is adapted from the example. Centered rect. Okay, let's copy this. So it's under UI, UIRS. Then you have UI. Okay. This will be useful for later subsections. We can see that there's a, so by the function name itself, it implies that it will be a centered rectangle. Okay, so that's why we have divide by 2 here. Usually when we want to center something, yeah, you divide by 2 to have it centered. In this case, it's vertical. And this one is horizontal. Okay. Let's just continue and see. Because we want the main screen to be rendered behind the editing pop-up, we will draw it first and then have additional logic about our pop-ups. our layout. Now that we have our frame, we can actually begin drawing widgets onto it. We'll begin by creating our layout. Let's come back to the previous one. I think I missed something. UI, okay, let's copy this. Let's put it here at the top. I'm just assuming it's over here. Okay. So this one, there's a layout vertical, so 3, 1, 3. Okay. And the variable chunks now contains a length. Okay, chunks. Length 3 array of rect objects that contain the top left corner of their space and their size. We'll use this later after we prepare our widgets. Okay, the title. Title is an important piece for any application. It helps the user understand what they can do and where they are. To create our title, we are going to use a paragraph widget, which is used to display only text. And we are going to tell that paragraph we want a border all around it by giving it a block. With borders enabled, see block recipes and paragraph recipes for more information about the block and paragraph. Okay, so let's just copy this. Let's append it here. So let title block. Okay, in this code, the first thing we do is create a block with all borders enabled, borders all, and the default style. Next, we created a paragraph widget with the text create new JSON styled green. See paragraph recipes for more information about creating paragraphs and styling text recipes for styling text. Finally, we call render widget on our frame and give it the widget we want to render. We want to render it. And the rect representing where it needs to go and what size it should be. This is the way all widgets are drawn. Frame, render widget, title, and then chunks. Chunk 0. Okay. The list of existing pairs. We would also like the user to be able to see any key value pairs that they have already entered. For this, we will be using another widget, the list. The list is what it sounds like. It creates a new line of text for each list item. And it supports passing in a state so that you can implement selecting items on the list with little extra work. We will not be implementing selection, so we simply want the user to be able to see what they have already entered. But where do we put this list? Render chunks 1. So earlier we had chunk 0. So okay, my assumption is I will just append it here. chunk 0, and this one chunks 1. Okay. In this piece of the function, we create a vector of list items and populate it with styled and formatted key value pairs. Finally, we create the list widget and render it. See, okay, list items from a vector. And then here, pairs keys based on the key for each key. List items push, so we're putting it inside list items. So there's some formatting here. Styling, there's some styling also. And then finally, list items. Okay, so this is, I assume it's a collection library also. Then you have a list. And then we're rendering the widget again. Pass in the list and then chunks 1. Okay. Oh, so the list goes in the middle because of chunks 1. I mean, that's just my assumption here because now we're seeing the bottom navigational bar. This could be the chunks 2. Okay, it can help new users of your application to see hints about what keys they can press. For this, we're going to implement 2 bars and another layout. These 2 bars will contain information on 1, current screen main, editing and exiting, and 2, what key bindings are available. Here we will create a vect of span, which will be converted later into a single line by the paragraph. A span is different from line because span indicates a section of text with a style applied and doesn't end with a new line. Okay. So this is still part of the UI. Let's copy this. My assumption is we can still append it here. Next, we are also going to make a hint in the navigation bar with available keys. This one does not have several sections of text with different styles and is thus less bold. Okay, so another UI. Let's copy this. Let's append it here. Okay, finally, we're going to create our first nested layout because the layout that split function requires a rect and not a frame. We can pass one of our chunks from the previous layout as the space for the new layout. If you remember, bottommost section of the above graphic, this one. Okay, 3. Constraint length 3. We'll create a new layout in this space by passing it chunks 2. Okay, so here we go. We have chunks 2. Let me copy this. The visual equivalent of this code is length 50, because of this percentage. Horizontal, so we are cutting vertical. So 50, 50, split chunks 2. Okay. And now we can render our footer paragraphs in the appropriate spaces. Footer paragraph, render widget. Okay. Oh, that was a lot. Then editing pop-up. Now that we have the main screen, now that the main screen is rendered, you now need to check if the editing pop-up needs to be rendered. Since Ratatui render simply writes over the cells with a rect on a rendered widget, we simply need to give render widget an area on top of our main screen to create the appearance of a pop-up. Need to give render widget an area on top of our main screen. Okay. The first thing we will do is draw the block that will contain the pop-up. We'll give this block a title to display as well to explain the user what it is. Do we have a function for the pop-up? We have centered rect. Where do we put this one? Okay, we don't know yet. So far, it only describes that there's a block here. Block, enter a new key value pair, borders none, style, dark gray, centered. Okay, centered rect is called here. 6025. Frame render widget. Pop-up contents. Now that we have where our pop-up is going to go, we can create the layout of the pop-up and create and draw the widgets inside of it. First, we will create split the rect given to us by centered rect and create a layout from it. Note the use of margin 1, which gives one space margin around any layout block, meaning our new blocks and widgets don't overwrite anything from the first pop-up block. Where's the margin? Margin is here. Now that we have the layout for where we want to display the keys and values, we'll actually create the blocks and paragraphs to show what the user has already entered. Key block, okay. Value block, tip style. Much editing. If key text, paragraph, what's in here? Render widget. Okay. By the looks of it, everything goes inside the UI function. It's just my assumption. Yeah, but let's see later. Now that we are declaring the blocks as variables and then adding extra styling to the block the user is currently editing, then we create the paragraph widgets and assign the blocks with those variables. Also note how we use the pop chunks layout instead of pop block layout to render these widgets into pop chunks. Where's the... Okay, so it mentioned it's using pop chunks and it's not using pop-up block. Okay, this is pop-up chunks. Okay, and then I think this is the last screen, the last UI. we have a way for the user to view their already entered key value pairs, and we have a way for the user to enter new ones. The last screen we need to create is the exit confirmation screen. In this screen, we are asking the user if they want to output the key value pairs as they have entered in the stdout pipe, or close without outputting anything. Yes, no. Okay, exit. Okay. The only thing in this part that we haven't done before is the clear widget. This is a special widget that does what the name suggests. It clears everything in the space it is rendered. Closing thoughts. This tutorial should get you started with a basic understanding of the flow of Ratatui program. However, this is only one way to create Ratatui application. Because Ratatui is relatively low level compared to other UI frameworks, almost any application model can be implemented. You can explore more of this in concepts, application patterns, and get some inspiration from what model will work best for your application. Finished files. Okay, so you can test this application by running by yourself by running. Okay, yeah, but I think we still have some compilation issues. Main RS. Oh, this is the entire main RS. Okay, so let's copy this one. Copy and paste. So let's remove everything. Go to line 1, V, Shift G, X, V. That should copy everything. No errors. It's not uses but mod UI. Okay. Not uses but use. I was trying use. Okay. Should be mod. And then main RS. Then app RS. Let's copy this. UIRS. Okay. Everything is compiled nicely. And then what was how do we run it? Cargo run test JSON. Nice. Create new JSON. Can we do up and arrow keys? No. Just what can we do here? E to make a new pair. Okay, E. Key test and enter value testing 1 2 3. Let's enter. There it is. And then press E again. Maybe key is message. Enter. Hello world. Enter. Okay, then if we press quit, and like, Oh, this one is difficult to see. Would you like to output the buffer as JSON? Yes. Okay, and let's see from here. There's test JSON. Yeah, test JSON is here. Do we do formatting in Visual Studio Code? Okay, there. Control Shift P and then format document. Yeah. All right, so that's about it. Although we just copied and pasted everything, maybe tomorrow we can go through once again, review the code here. I think it's easier if we started with the code already prepared. Yeah, but then this is live. We dissect the code again tomorrow or the following day. Yeah. So that at least we should be able to learn something and maybe move things around, experiment, and hope you would join me tomorrow, yeah, or the next day. All right, so let's end here and let me thank my supporters. Thank you so much.